Dust storm. You must take cover quickly when a dust storm happens. Now, as the dust settles, let us discuss the facts behind the phenomenon known as dust storms. A dust storm is a meteorological phenomenon caused by strong winds that carry loose sand particles. This type of phenomenon happens in arid or semi-arid regions where there are vast amounts of loose sand. In these desert regions, dust storms occur regularly. It is estimated that as much as 80 dust storms occur every year. A sandstorm can carry a lot of dust, estimated to be about 1.6 kilometers thick. Sandstorms are caused by strong winds blowing over loose soil and dust particles. Strong winds are the result of storms and other changes in atmospheric pressure. Meanwhile, the loosening of soil and dust particles are the result of many related conditions. Wind blowing over solid masses of rock and soil tend to degrade and loosen small particles over time. A lack of precipitation or drought also causes dried up soil and sand to become loose. Activities like farming and other processes that involve digging through soils also contribute to its loosening. When strong winds blow over these loosened particles, you get a dust storm. Let's take a look at the effects and hazards that dust storms cause. In instances of very strong wind, dust storms are known to take down trees. The dust that it leaves behind usually covers equipment and other items that are left outside during storms. This includes vehicles, machinery, lawn equipment, signage, streetlights, tents, and other items typically found outside houses and buildings. These can cause structural as well as internal damage. Buildings and houses are also prone to damage as the wind coupled with particles accelerate wear and tear by way of friction and abrasion. Unsecured and poorly built structures are also prone to being carried away in more extreme conditions. Visibility takes a dive during dust storms. That's why land and air transportation is usually disrupted. Exposure to dust storms are also detrimental to certain species of animals. Dust can affect their breathing, which can lead to animal casualties. Physical injuries caused by dust storms are also common. Sandstorms also affect plant life and vegetation. It can destroy crops and strip the soil of nutrients, thus stifling agricultural activity and food production. While winds cannot be stopped, there is still something that can be done to lessen the formation of loosened soil. Among them are agricultural solutions like planting trees and grass and shifting to sustainable farming practices. People living in dust storm-prone areas prepare by covering cars and outdoor equipment with a secure and dust-proof fabric. Goggles and gas masks are also advised to be worn to protect one's face and prevent dust storm-related conditions. Clouds. If you look up in the sky, you'll see them. A floating mass that sort of resembles cotton-like structures of different shapes and sizes. clouds. So for now, let's take a closer look. So, what are clouds? Well, previously, we have been introduced to clouds as condensed water vapor floating in the Earth's atmosphere. More specifically, a cloud is a visible aerosol that consists of a mixture of liquid droplets, frozen crystals, and some other particles suspended in the atmosphere. Cloud formation is also a part of the natural water cycle. When evaporation occurs, water from oceans, lakes, rivers, and other places on the surface of the Earth turn into water vapor and travel through the atmosphere. As the water vapor travels higher into the air, it gets cooler and eventually condenses into small water droplets and sometimes even ice crystals. Water vapor will also combine with other particles in the air, such as dust, smoke, and pollen, to form what is called a condensation nuclei as it condenses. The small water droplets and ice crystals is what gives the cloud its visible appearance. Oftentimes, clouds appear white, but sometimes they can also look grayish. This is because water droplets and ice can scatter and reflect light. Clouds reflect sun rays, which makes them appear white. But as clouds increase in mass and become thicker, there is less light to reflect. This makes clouds appear darker and is also an indicator that it is about to rain. Clouds are usually classified based on the altitude or height where they are formed. Clouds formed above 20,000 feet are usually termed with the prefix cirro or cirrus. These types of clouds are mostly made up of tiny ice crystals and have a feathery appearance. Clouds formed between 6,500 to 20,000 feet have the prefix alto. These clouds are made up of a combination of water droplets and ice. Clouds formed at 6,500 and below are called stratus, and they are mostly composed of just water droplets. There are also vertically formed clouds, clouds that are formed in between the different levels of the atmosphere. These are called cumulus. Clouds are usually described by combining the naming terms that describe them. For example, cirrus clouds are thin and wispy. These usually indicate good weather. Altostratus clouds are dark and gray clouds, an indicator of rainy weather. Nimbostratus clouds, on the other hand, are thick and gray. They usually indicate either rainy or snowy weather. In addition to that, clouds also serve another useful purpose. Clouds provide some shade from the heat and light of the sun, and thus directly affect the temperature of the Earth's surface. Being part of the water cycle, clouds are part of the planet's greater weather system. And observing clouds provides useful data and insights into reading and predicting the weather. Lightning. This often accompanies stormy weather. Nature's awesome display of light and energy. It can only be lightning. Lightning is what is called an electrostatic discharge. This occurs when the electrically charged regions in the atmosphere and the ground equalize and release a sudden burst of energy. This energy is so strong that it can contain as much as 5 gigajoules of energy, which is approximately equivalent to the energy of 38 gallons of gasoline. Lightning needs very specific conditions for it to occur. Electric charges in the atmosphere are caused by the ionization of air molecules due to being exposed to cosmic rays from outside the Earth. When these collide with air molecules, they get charged. As more water vapor in the clouds freezes, the small bits of ice bump into each other and cause the cloud to build up an electrical charge. Positively charged particles gather at the top of the cloud, and the heavier negatively charged particles move to the bottom. When the charge grows large enough, the energy can no longer be contained and must be released. It will travel in the direction with an opposite charge as lightning. Of course, we can't talk about lightning without discussing the accompanying sound it makes, or what's more commonly known as thunder. Lightning carries enough energy that can create heat at temperatures of about 25,000 degrees Celsius. This causes surrounding air to rapidly heat and expand at a rate that is faster than the speed of sound. This effectively creates a sonic boom effect, and this is what makes the loud, boomy rumbling noise of thunder. There are mainly 3 kinds of lightning, as categorized by where they are formed. First, lightning can occur within a single thundercloud or intracloud. Second, lightning can also occur between 2 different clouds, or cloud to cloud. And lastly, lightning also occurs between a cloud and the ground below, or ground to cloud. Lightning has several devastating effects because of the immense amount of energy that it contains. Trees and plants hit by lightning may catch fire. Animals and humans alike may suffer from injuries to their organs and nervous systems after being struck by lightning. Lucky for us, however, statistics say that 90% of people struck by lightning have survived. Tall structures and buildings are more likely to get struck by lightning, although there are generally no dangerous effects. Man-made structures called lightning rods or lightning arresters have been constructed to be specifically hit by lightning. This helps prevent unwanted accidents and are also sometimes used as tools to study lightning phenomenon. Lightning also plays a role in the nitrogen cycle. By oxidizing nitrogen and releasing nitrates into the air. This contributes to the growth of plants and organisms. Rain. Water falling from the sky. Let's talk about rain. Rain is the most common type of precipitation, or simply water that is released from clouds. Due to the Earth's unique atmosphere, the air around us is full of water, even though we cannot see it. When discussing rain, it is also important to discuss the water cycle or the natural processes that our planet's water goes through. Let's take a look. First is the process of evaporation. When water is heated, it undergoes a change from a liquid state to a gas state. The heat that triggers this process comes from the sun. This process can be observed in many ways, like the drying up of puddles in the street, or air drying laundry during a sunny day, and so on. When water evaporates, it becomes lighter. But as it reaches the atmosphere, it undergoes another process called condensation. Here, the water vapor condenses into small water droplets, which form clouds in the sky. The water vapor in the clouds are very small, and thus are able to float freely in the air as clouds. But when more and more water vapor forms in the clouds, they become bigger and heavier. The bigger and heavier water droplets combine with other particles in the air, such as dust, salt, or smoke, and form even bigger droplets. These bigger droplets undergo more condensation, and when the droplets are big and heavy enough, the result is water falling back to the ground, or simply rain. Now, in some cases, precipitation may also appear in different forms, aside from rain, given the right conditions. At freezing temperatures, water droplets in the air may freeze before falling to the ground. This is more commonly known as snow. Sometimes, water droplets may freeze and be sucked up again in the atmosphere, causing layers of water to build up and freeze over time. This eventually forms a bigger ice pellet, or what is more commonly known as hail. Rain can also be supercooled, which means that the water droplets retain its liquid form, but freeze upon hitting the ground. Now, let us take a look at the shape of raindrops. Water droplets that have a radius of 1 millimeter usually appear round. But as droplets grow in size, their bottoms usually get flatter. At 3 millimeters, there will be a visible indentation at the middle of the droplet. And finally, at around 4 to 5 millimeters, the indentation breaks the water droplet in the middle, forming a parachute shape which results to smaller droplets. Rainfall over different regions of the Earth are different. This has something to do with the position of certain areas on the Earth. Deserts usually experience less rainfall because they are located in places that receive more sunlight and are therefore warmer and drier. On the other hand, regions in the tropics receive more rainfall than other places. While rain is mostly just water dropping back to the earth, given the conditions like wind and the temperature, rainfall can be part of storms where massive amounts of rain can cause flooding and other hazards associated with it. El Niño. This phenomenon might sound a bit peculiar to some and may be more familiar to others. Let's talk about El Niño. To our Spanish-speaking audiences, El Niño literally translates to the boy. But for meteorologists and people whose livelihoods depend on the weather, it is a whole nother thing. El Niño is part of the warm phase of what is known as the El Niño Southern Oscillation, or ENSO. The ENSO is a cycle of warm and cold temperature on the surface of the sea. This usually occurs in the tropical central and eastern regions of the Pacific Ocean. El Niño is characterized by the presence of warm ocean water in the central and eastern central Pacific. It is usually accompanied by high air pressure in the west and low air pressure in the east, affecting areas and regions close by. The term El Niño actually comes from the El Niño de Navidad, based on the Spanish term for newborn Christ, a reference to Christmas. This is because fisherfolk from South America usually observe the warming of waters during the Christmas season. But accounts and actual occurrences of El Niño may vary. And actual El Niño events have been observed to occur from 2 years to as long as 7 years. Because of the changing of the sea's temperatures, El Niño drastically affects normal weather patterns. This causes strong and intense storms in areas of low pressure, while in other places, little to no rain at all, even causing drought in some areas. Let's take a look at how El Niño's effects vary from different regions on the planet. Places near the equator like Indonesia and the northern parts of South America receive below average rainfall, while regions in South America near the eastern Pacific Ocean receive increased rainfall and thunderstorms. On the other hand, countries in Africa experience wetter than normal conditions from March to May, and drier than normal weather during December to February. In the Asia-Pacific region, El Niño usually causes extensive drought. Reduced rainfall is also observed in Australia. And because of the way El Niño affects the weather, it also has varying effects on humans. Countries with economic industries built on fishing and agriculture might be severely affected because of droughts and storms. Fish also behave differently, sometimes changing migration patterns to avoid the warm regions of the ocean. Coral beds and sea habitats are also damaged by the rising temperature. This contributes to less supply for commercial fishing. Extended periods of drought also affect the ecosystem as plants and trees receive less rainfall. Another consequence of drought is the increased risk of forest fires. And finally, the changing of the weather also affects human health. The risk of tropical diseases transmitted by mosquitoes, such as dengue and malaria, are often related to shifts in the weather. And given the right conditions, El Niño may directly contribute to its increased transmission. We are nearing the end of this episode. But before we go, let's take a quick recap. In this episode, we talked about dust storms, the weather phenomenon caused by strong winds carrying loose sand particles, and the arid desert regions where these usually occur. While dust storms cannot be stopped, better ecological and agricultural practices may help lessen its harmful effects. We also learned about clouds, a visible aerosol that consists of a mixture of liquid droplets, frozen crystals, and some other particles suspended in the atmosphere. Clouds also have different sizes and shapes. Cloud formation is also part of the water cycle and the Earth's weather system. We also discussed about lightning, an electrostatic discharge that occurs when the electrically charged regions in the atmosphere and the ground equalize and release a sudden burst of energy. We also discussed how this naturally occurring phenomenon is accompanied by a loud rumbling noise called thunder. We discussed how rain is formed from the water vapors in the atmosphere as part of the planet's water cycle. From evaporation to condensation, and finally precipitation. Different parts of the Earth receive different amounts of rainfall. This has something to do with the different regions of the Earth having different climates and geological features. And finally, El Niño is a weather phenomenon that is part of the ENSO. It is characterized by the changing of surface temperatures of the ocean in Central and Eastern Central Pacific. This change of temperature causes a shift to usual weather patterns, often causing excessive rain and prolonged droughts, depending on the geographic location of affected regions. And with that, another episode comes to a close. We hope you had a fun and informative time watching. But until then, keep safe. Stay dry and warm when you can. And we'll catch you next time for another rain-inducing, storm-brewing episode of Nature's Force. Seasons. You may not realize it, but these definitely affect us more than we might care to admit. Our clothes, our weather, the environment, and even our activities. Have you guessed it? We are talking about, of course, winter, spring, summer, and autumn, or simply the 4 seasons. Now, the way we experience seasons varies depending where you are located on Earth. Places near the equator experience somewhat similar weather with slight variations all year round. While for regions in the northern and southern hemisphere, seasonal changes are more definitive. Like, say, the difference between summer and winter, or spring and fall. But why do seasons happen? Well, this has something to do with how our planet is tilted towards the sun. Because of this tilt, parts of the Earth's surface lean closer to the sun, depending on the time of the year. Areas that are tilted towards the sun are more exposed to the light and heat, and therefore become warmer, or what we commonly know as summer. While the areas tilted away from the sun become cooler and experience lower temperatures, or what we commonly call winter. While other areas, which are parallel to the sun, experience autumn and spring. But wait, didn't we mention that places near the equator experience seasons differently? That is because their unique position on the Earth means that they pretty much receive consistent heat and exposure to the sun. There is also another factor that affects the seasons in the regions of the Earth. This has something to do with the Earth's orbit. Having an elliptical path means that there are certain times of the year where the Earth is farther from the sun, which means less heat and lower temperatures. Now, let's take a look at seasons. Spring is typically associated with warm and wet weather. This is the usual time for harvest. For some animals, this signals their time to awaken from hibernation. Summer is when things get hot. Summer is the season associated with the highest temperatures of the year. The period where a particular region is closest to the sun. This is also the period where spikes in temperatures may happen, which can cause heat waves. On the other hand, autumn is the season where temperatures start to cool down. For some animals, this is the period to gather food and prepare to hibernate for winter. For migratory animals, this is the time for them to move to warmer regions. And one of the most noticeable features of autumn is when plants shed leaves and become dormant. That is why autumn is also called fall. And finally, we have winter, the coldest season of the year. This is when temperatures drop and cause precipitation in the air to freeze, or more commonly known as snow. For hibernating animals, this is the time to undergo a resting state. While humans need to adapt to the cold with the help of warmer clothing and by staying indoors lest we freeze. Drought. Hold on to your farming hats, because this one is about to get hot. So hot in fact that we might just need water. Well, that's what we are going to talk about today. Let's talk about droughts. In the past episodes, we have been learning about precipitation and rain. But what if it doesn't rain? Well, that's exactly what droughts are. A period characterized by below normal precipitation in a given region that causes shortage in the supply of water. Without any rain or precipitation, soil may have reduced moisture. Groundwater reservoirs may become depleted, crops might get damaged, and there might be water shortages. Can you imagine that? Now, there are many factors that can contribute to drought, so let's take a look at them. One of the main reasons for drought is low precipitation. This meteorological phenomenon is caused by high amounts of reflected sunlight and the prevalence of high-pressure winds that usually prevent the formation of storms and rainfall. Another cause of drought is the natural occurring dry season due to the movement of the intertropical convergence zone, or monsoon trough. During the dry season, more water vapor is required to reach humidity values to 100%, which in turn triggers precipitation or rainfall. Another cause for drought is the El Niño, the meteorological phenomenon associated with warm dry air spreading in the central regions of the Earth. While these are naturally occurring, human activities involving farming and agriculture, deforestation, and erosion may also contribute to droughts. Farming usually involves massive amounts of irrigation, while industrial activities, which cause soil erosion, may impact the natural ability of plants to hold water. Now, as we all know, water is essential to life, and so droughts in themselves have very significant implications to humans and the environment. Droughts can affect water supply, which means it not only affects humans, but animals and plants as well. Excessive periods of drought can be detrimental to biodiversity of the environment. Forest fires are another consequence of drought, and without enough water supply, these may worsen too. When talking about droughts, there's also a high impact on the economy, especially in industries that are dependent on water. These include agriculture, farming, fishing, food supply and production, hydropower, mining, paper, and many more. And last but not the least, the social and health implications of drought for humans, including heat-related sickness, malnutrition due to food and water shortage, increased levels of pollution, and the list goes on. But while some forms of drought cannot be completely avoided, there are fortunately some steps that we can take to mitigate its effects. These include measures like dam construction, cloud seeding, and utilizing seawater through the process of desalination. Land use planning is a series of measures that include crop rotation and the utilization of crops that require less water. Other measures include water conservation, like restricting water at home, regulating sprinklers, pools, and etc. Other steps include harvesting rainwater and recycling wastewater to be clean enough to be used again. And finally, data on droughts and the weather can also be used to monitor and predict when large-scale drought may occur, and thus allow us to prepare if the need arises. Hurricane. For this next one, you better stay indoors because this might blow you away. Let's talk about hurricanes. Hurricanes are tropical cyclones or storms that are usually characterized by a low-pressure area. It moves in a circular motion and often comes with strong winds and sometimes with rains and thunderstorms. The term hurricane is used to define tropical cyclones that occur in the Atlantic Ocean and the northeastern Pacific Ocean. They typically move in a cyclonic fashion or in a counterclockwise rotation. These two are what differentiates hurricanes from another type of tropical cyclone, the typhoon. But other than that, the same natural processes that are involved in the formation of a hurricane are the same. And with that, let's move on and take a look at how hurricanes form. Hurricanes develop during the summer, when the ocean air is warmer. The warm and cool air undergoes convection, where they move together and form an area of low pressure, causing the movement of winds. When the surface winds converge towards each other, they start to circulate and their speed increases. As they move faster, they form an identifiable center, and this is now classified as a tropical depression. When the speed of the wind reaches speeds above 63 kilometers per hour or 39 miles per hour, the tropical depression is now considered a hurricane. Hurricane speeds do vary, as well as the force that they exert. Hurricanes carry strong winds, and this is usually accompanied by strong rains and, of course, flooding. In some instances, this strong wind and flooding can cause detrimental effects to humans and the environment, including the disruption of shipping and fishing activities due to the strong winds and the waves that it causes, making seafaring and related industries very unsafe. Hurricanes are also known to damage and sink ships, causing shipwrecks. And you need not look far for proof. Many shipwreck stories from history will attest to that. Now, land-loving dwellers are not safe either, and will experience their share of the hurricane's force. Strong enough hurricanes can cause terrible damage to property, destroying houses, buildings, infrastructure, and vehicles along its path. People and animals, including pets and livestock, are also very much at risk during these times. Power outages are common as well. And speaking of health, Flooding brings with it waterborne illnesses, which become prevalent during hurricane season. And so, what can be done to mitigate these effects? Well, while hurricanes cannot be completely avoided, there are systems that help us forecast their occurrence and movement, albeit only a few days before they reach populated areas. These include satellite imaging for storm forecasting, as well as years of data from previous hurricanes. The good news is, we can prepare for such events. Aside from forecasting, governments and authorities have put in place risk assessment measures, especially for hurricane-prone areas. These include preparing adequate supplies of food, medicine, emergency power sources, and other tools. In certain situations, evacuation may also be the preferred way to prepare for devastating hurricanes. Thunderstorm. Now, it's time to cover your ears and stay indoors once again, because this next one is about to get loud. Did you hear that just now? That was the sound of thunder in a thunderstorm. A thunderstorm is a storm that is characterized by the presence of cumulonimbus clouds that produce lightning, and of course, its accompanying acoustic sound, thunder. Now, when discussing thunderstorm formation, we have to start with the wind and clouds. Warm air rises, carrying moisture and water vapor. These then condense and form into clouds. As the water vapor condenses, it releases energy in the form of latent heat from condensation. This release pushes the cloud higher into the sky. If the conditions are right, this process continues until the clouds form into cumulonimbus clouds. These are the dense, towering clouds usually associated with lightning and storms. Thunderstorms undergo 3 stages. Let's take a look. The first stage is called the developing stage. This is the stage where cumulonimbus clouds form from the condensation of water vapor. As the clouds release latent heat, they move higher and create an updraft of air. This then creates a low-pressure zone and a storm beneath it. The next stage is called the mature stage. This happens when the rising warm air can no longer rise any farther. As the rising air has nowhere else to go, it is forced to spread out. This is the reason why storm clouds usually have a very dense anvil shape. During this stage, water vapor in the clouds coalesce into bigger droplets. These droplets may in turn become precipitation in the form of rain, or if the temperatures are low, may fall as hail instead. This stage is also the time when strong winds and lightning forms, and in some extreme cases even, form tornadoes. And finally, the last stage is called dissipation. At around 20 to 30 minutes into the storm, the downdraft of the air will push the storm to the ground and spread it out. The cool air carrying the storm downward cuts the inflow of the thunderstorm and causes it to dissipate. Thunderstorms are known to be very destructive, and so it is advised to stay indoors during one. Thunderstorm hazards include lightning, hail, tornadoes, flooding, and strong wind bursts. There are also findings that these can trigger allergic reactions, such as asthma. While all thunderstorms will eventually dissipate, some thunderstorms may become severe, and with it, the increased risk to human safety. Thunderstorms, after all, can pretty much happen all year round, and so safety and preparedness is paramount. Tuning in to weather forecasts can help one to be alert and prepared in case of a brewing thunderstorm. If you are outside during one, seek shelter, or better yet, stay indoors. Avoid open areas like hilltops, fields, and beaches. It's also a good idea to avoid tall objects like trees and towers during a thunderstorm. Solar flare. Get your sunblock ready, because it's about to get hot. And no, we're not talking about summer, because for today, we are talking about the sun, but more specifically, solar flares. So off we go from Earth, and let's take a look at space. Now, we all know the sun, the star that is at the center of the solar system, where of course the Earth lies. It is our primary source of light and warmth. But did you know that beyond these are countless physical and chemical reactions that create the immense energy of the sun? A closer look at the sun reveals large explosive movements that are reminiscent of wildfire. What these are in fact are what is called solar flares. Solar flares are the bright flashes that can be observed on the surface of the sun. These emit a wide variety of energy types. The energy released by a solar flare is typically around 1 × 10 to the 20th power joule. Or you can write that as 1 followed by 20 zeros. Now, to put the energy into perspective, you can think of it as the same amount of energy as a volcanic eruption, only 1,000,000 times stronger. But the energy of a solar flare does not stop there. A stronger type of solar flare event, called major solar flare event, can reach energy levels of about 1 × 10 to the 25th power joules, which is roughly the equivalent of 1 billion megatons of TNT. Aside from the immense energy, solar flares also eject clouds of particles made up of atoms and ions. Sometimes, these particles even reach Earth after 1 to 2 days. Now, let's talk about how these things occur. When electrons speed up and interact with the plasma on the surface of the sun, this causes the phenomenon of magnetic reconnection. When this happens, a large amount of energy is released along with a big eruption of energy emissions. So, how do solar flares affect the Earth? Well, solar flares influence what is called space weather near the vicinity of Earth. Emissions from solar flares also produce what is called solar wind, which can affect the Earth's magnetosphere. This also carries harmful radiation, which is especially harmful to spacecraft and the astronauts in it. In extreme cases, solar flares can cause a coronal mass ejection, or CME. This release of energy is known to cause massive interference, which can disable radio satellites, causing disruptions to Earth communication systems, which include radio, TV, broadcast, cellular communication, navigation, and even the internet. Imagine, just a single CME can cause such widespread damage. But that's not all. CMEs are so powerful that they can also disrupt power grids, which can cause blackouts to communities. We are nearing the end of this episode. But before we go, let's take a quick recap. In this episode, we learned seasons are divisions of the year which are based on changes in the weather. Some regions of the planet experience 4 seasons, while others only 2. The changing seasons on Earth are caused by the Earth's tilt and rotation. These factors affect the amount of sunlight that different regions receive, which in turn affects the weather. Droughts are prolonged periods of time where a region receives little or no precipitation. Droughts can be caused by many factors, including high amounts of sun exposure, a regularly occurring dry season, the El Niño phenomenon, and high amounts of high-pressure air. Hurricane is the term used in regions in the Northeast Pacific and the Atlantic to refer to tropical cyclones. Storms that are caused by low-pressure areas that are formed by the rising warm air in the oceans. A thunderstorm is a storm that is characterized by the presence of cumulonimbus clouds and lightning, as well as the accompanying sound of thunder. Thunderstorms usually come with strong winds and large amounts of precipitation, and in extreme cases, even tornadoes. And finally, solar flares are the strong explosions at the surface of the sun. These are caused by the interaction between electrons and plasma on the sun's surface. Solar flares cause a type of emission called CME, which can cause interference with the Earth's power grids and communication systems. And with that, another episode comes to a close. We hope you had a fun and informative time watching. But until then, keep safe. Stay dry and warm when you can. And we'll catch you next time for another rain-inducing, storm-brewing episode of Nature's Force.